Okay, so people are questioning flow control and hard coding ports. So all I can tell you is what I do. So if you go back and you watch the first video I released, Netonix the movie, I go into more detail and I go through a lot more of the switches. But I just picked this one up because I remember the IP address. This is one of my typical towers. You'll notice in the ports section they're all set to auto. And I have flow control turned on, and in the newer version of the firmware it actually tells you if it's negotiated flow control with its partner, which we also go over in the video. But so at any given tower, and they all pretty much mimic each other, I have all the ports set to auto because flow control is a function of auto. And to be honest with you, you really don't want to hard-code a port. You'll get worse performance. Even Cisco tells you you only hard-code ports when you have to, that you should use auto. So this is Hillcrest. Hillcrest has 4 backhauls. Once again, under the VLANs, you can come in here. This is the Hillcrest at Georgetown. So it's set up as a mid-span. Hillcrest at Bearville, Quarry Road, and Stumptown Road, which is the backup link. So anyway, you can see I upgraded the switch not too long ago, I guess about 8 days ago, but it's been up and running. There's no errors on any of the interfaces. It's talking to everything from AirFiber 24s to Rocket M5s. There's Mimosa B5Cs, and then a whole bunch of Rocket M5 access points. Once again, all set to auto, all set to flow control. It's important to have flow control from the radio to the switch, and then from the switch to the router. I choose not to run my backhauls through the same uplinks to the local radios in the tower because the local radios are going to generate more pause frames with flow control, and I don't want traffic that's migrating from one tower to the next in the ring to be hindered by the flow controls that are created by the local APs. To give an example, this is Hillcrest. So I'll bring up a very rudimentary map. Don't nobody laugh. But anyway, this is basically part of my network in a nutshell. The gray cloud here is representing where the internet comes in at, which is 2 level 3, 1 gig fiber optic ports, dark fiber that we light up. If we zoom in here a little bit, so this line here is an AirFiber 24 HD. This orange line, which is a good color for Mimosa, is the Mimosa backup link. So the main AirFiber 24 shoots into a tank called Quarry Road. Quarry Road then feeds Hillcrest, feeds Bearville, feeds Diller Ave, feeds a railroad grain mill, feeds Blue Ball water tank. By the way, the round ones are all water tanks. This is a Trilon 96-foot tower we have up on top of the hill that we built. That shoots over here to another water tank in another town called Akron. That shoots back to Quarry. So this is the main link. And all of these purple lines are air fibers. This one link here is over 6 miles. That's an air fiber 5X. But all these other ones, this link here is like 3+ miles. That's air fiber 24. This is 3+ miles, air fiber 24. This is 1 mile. That's an air fiber 24. This is, I think that's 3-point-some miles. That's Diller to Bearville. And then Bearville to Hillcrest is like just under 2 miles, and then Hillcrest to Quarry Road is just under 2 miles, and then Quarry Road to Akron is just under 4 miles. If you zoom out a little bit more, the green lines are currently AirMax M5 backhauls to some rural areas that we cover, but I think my guys are in the process of upgrading those to AirFiber 5Xs. But that's like a 10-mile link to a tower we call Georgetown. It's 375-footer. Then it's 10 miles over here to a tower that we call Honeybrook, which is a 175-foot cell tower we co-locate on. And then that's like a 6-mile link, I think, that shoots from there to Terry Hill, which is the Trilon. There are some other weird rings. This is a backhaul that goes out to an industrial park near Lititz, Mannheim area, and then it goes around out there, and then this one comes out back in through from that airport, and then these go into the city. We don't really do coverage in the city, but we have 2 large accounts in there that we do provide service for. One's a financial advisor group that I use as a courtesy, and the other one is our law firm. So you want to keep your lawyers happy, right? Plus, they spend a lot of money with me. That's a 100 megabit dedicated pipe for them. Anyway, which performs better than their Comcast system that they had. Anyway, I'm in this red box here. This is a big commercial building in an industrial park that I rent for RF Armor and Netonix. There's many tenants in here. I'm in this back corner. That's why I'm called 5C. I do a bad thing and I shoot across the building. I'm about 80 feet above the roof line, which is not enough, so I have Fresnel encroachment across it. But then from here to Diller Ave, it's like 3 miles. I'm connecting into an access point like everybody else. Anyway, I think that AP it's not heavily loaded though. I think there's like 10 people on it. So from here, I'll have a Nano Bridge M5 shooting to the access point, goes down the tower into the router, and we'll come back up and then shoot across this air fiber to here, go down into the router, come back up, shoot across the next air fiber, does the same thing. It'll skip this Mimosa link because OSPF says don't use this right now because it has a higher cost. Then it'll shoot across that air fiber 24 link, go down and back up, and then shoot across another air fiber 24 link to this. And this is called Stumptown. So we'll bring up a couple pings here. Please don't laugh at all the tabs I have open, and this computer kind of sucks. It's very slow. Let me close some of this stuff here. So this is me pinging 8.8.8.8, and this here, I'll ping SR1 in the map. SR1 is the fluffy cloud. That's way over there on the Amish farm. So from me to there, I'm giving you that IP address because it's invalid. I don't care. 4 milliseconds. Whoop. Let's do it again. 383. You know, it's not too bad. We can do it constant for a little bit. Once again, this machine is a shipping computer that I use when I'm here. Which is why there's UPS World Ship on here. So I have very good latency at the front end, and keep in mind that that's traversing all the way from the red box to the gray puffy cloud. You know, all those hops, all those routers. It's going through my little NAT router, which I'm using the Nano Bridge as the router here at the warehouse, to a Cisco 2951. Down and up, Cisco 2951, down and up, Cisco 2951, down and across, Cisco 2951, down and across to our head end router. I think we still have a 2951 at the head end too. I'm not sure. I have to talk to Tom. I don't work at my WISP every day anymore. Anyway, you can see really nice pings. And then I'm pinging 8.8.8.8. So we're going to do a speed test. If I can drag some stuff out across here. We'll go to speed test. You can see this was the last test, so I'm pretty sure I know what I'm going to get. We'll say new server just so you guys can see what I'm picking. So you can see where I'm located at. And where I was picking in the test, I just picked Washington, D.C., and I picked this hosted by SoftLayer Technologies. So once again, this machine is a little clunky, so we'll see. You can see it's having a difficult time loading some stuff up. It's not a speed teamster. You don't need much to do shipping. So I'm on a 20 megahertz AP with a maximum capacity of 70 plus megabits. You can see that I'm saturating the links a little bit. I mean, it's more obvious on these normally lower pings than you see fluctuating to 8.8.8 because, you know, they were already double digit. So you saw the fluctuation there. But I got 52 down. Once again, the upload is going to be worse because I'm shooting across the building, and the Fresnel encroachment is going to be much worse shooting out than it is coming in. But I'm sure that the Fresnel encroachment of shooting across my roof is not helping either direction. So there you go. Now, of course, you'll probably miss a ping here. It always seems to do that whenever after you finish the speed test sometimes. But it did miss a ping to the 8.8.8. But now that I'm not saturating my link, my latency to my head end has pretty well settled down. I mean, I don't know what to tell you. I can pick a new server. We'll go to actually Speedtest and stay in Washington, D.C. That's where all the money is, right? Politicians. So not quite as good. Once again, it's obviously more, the link saturation is more apparent on this ping because it's normally 3 or 4 milliseconds. But somebody pinging the real world out there, they're probably not going to notice those 10 milliseconds during saturation. But all in all, it's pretty robust. I mean, this is connected through an AP like all my other customers. If I go down to my WISP and do a speed test from there, this is an radmin into my desktop where I sit at Netonix, my WISP. I thought I had speed test up here. This machine's a little bit better, but you can tell. So we'll do the same test to Washington, D.C. Now, the office has a fiber connection to Hillcrest, and then Hillcrest, let's see if I have a ping. I normally have pings running all over the place, but so it's okay. Probably get a lot better out. I mean, it is 5:30. I left the full screen record on so you could see the date and time here. But so I mean, prime time has already begun. I missed a ping there, but missing a ping can be anything. Keep in mind we build our network at our office out of stuff that we usually take away from customers. So that's not too bad. So going back to the map, where my office would be would be probably somewhere around here, and then it would have a direct fiber connection to that tank. So we ran fiber down 23 and then down the road and stuff. So from my office, I got 243 down, 392 up. I mean, at night when nobody's on my network, I've seen it go as high as 600-700 megabit, but that's about the limit, because even though we have an AirFiber HD here, this link here is a standard AirFiber at this time, so it's limited to 700 megabit. But from the office here, in reality, just so you know, I mean, I was going across to here, and then shooting across to here, and then shooting across to here, and then shooting across, and shooting across here, and then finally down to there. So, and how I have my switches set up. So, this is Hillcrest. I picked Hillcrest because I know the IP off the top of my head. That would be this guy right here. That guy. So, first thing I want to show you is there's no errors, right? Okay, set your links up right, there's no errors. Ports all set to auto, flow controls on. If you go back to the longer video, I talked about legs. I mean, I have the legs set up to serve the local APs and stuff on the tower, and then I have the mid-span VLANs set up so that routed backhauls don't go through that leg, and that's to prevent the flow controls to be the access points are going to generate a high number of flow control pause frames. If you look at the individual access points, there's going to be no pauses, no receives. Obviously, there's no RX pauses because the switch is going to get a pause from the access, or the access point, and then push that pause frame back to the interface facing the router. Essentially, kind of oversimplifying it. It's not exactly how it happens, but anyway, these are the interfaces facing the router, and you'll see that these interfaces have a large number of pause frames, and those are because the port's overflowing, trying to feed these 10100 devices that say they have a physical link of 100 megabit full duplex, and in reality we know they're much less, and that they vary from moment to moment. But if you look at the interfaces facing the air fibers, there will be some pause frames on them as well. Not nearly as many. An RX pause frame. So that means that the air fiber 24 actually asks my switch, please slow down, you're feeding packets to me too fast. And then same thing over here for the going out the other direction. You're going to see the pause frames there. So I mean, I don't know what to tell you. You want flow control. It makes things run better. You don't really want to hard code your port speeds. I mean, that's up to you. So anyway, we'll do one last speed test here. I guess maybe just to prove to you where I'm at. So if I do an IP config, so 192.168.1.1 is my gateway. And if I go to 192.168.1.1, that's going to be my NanoBridge login. I don't really want to log into it because my IP addresses are going to be there. So you're just going to have to trust me on that one. But one last test. This is the slower of the two test servers. So, and this hesitation you're seeing in the beginning, once again, I want to stress, is the computer that we're working on here. Probably hasn't been rebooted in a long time. Although that's actually kind of reasonable as we get further into the evening. We're going to hit more and more prime time. So the Netflix and the Hulu boogies. Although I'll test one more time just to the faster server to see if it was this machine switching windows or if my network's actually slowing down a little bit because of prime time. So painfully waiting for a new server. Oh, well, that's interesting. Didn't give me a chance to pick a new server. So we'll just stop you and refresh you. How's that sound? Jerk. Alright. Load up all the ads. Have you noticed over the years there's been more and more and more ads on Speedtest.net? Those guys are going to make a killing. Probably get bought out by somebody. Anyway, this was the faster one. But as I said, I'm shooting across the building. I have Fresnel zone encroachment, blah, 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 and this machine sucks. Well, I guess that is not too bad. That's better. Maybe it's because we have Raisin Bran on the screen. Good stuff, guys. Good stuff. I guess I should bring up the ping for you. And I should be able to see that. So 60 by 98 should actually, well, I guess it's kind of hard. No, I guess that really wouldn't be enough to show up on the graph of that. That's a lot. There's a lot of people on there. That's 300 megabit going in and out of that backhaul. So anyway, that's all I can say with speed test and flow control. FedEx, yuck. So that's it, guys.